Good morning, friends. Today we are going to discuss Leetcode daily question, which is numbered as 2616. Minimize the maximum difference of pairs. Uh, we'll go through the question. You are given it's a median level problem. You are given a zero indexed integer array nums and an integer p. Find p pairs of indices of nums such that the maximum difference amongst all the pairs is minimized. Okay. Also ensure no index appears more than once amongst the p pairs. Okay, note that for each pair of elements at the index I and j, the difference of the pair is absolute values of nums of I minus nums of j. Return the minimum and minimum maximum difference among all pairs. We define the maximum of an empty set to be 0. So, uh, you can take one. So, as soon as you see minimum maximum difference, as soon as you see the wordings of minimum maximum of something, you the pattern you need to think it of is a binary search kind of pattern. That is the first thing. First we'll go through examples. Here they are asking for I need two pairs. I need the very lowest absolute difference of lowest two pairs and maximum and the maximum value among those two pairs. That's what they are saying. So accordingly they are picking the values and they have found that the two least absolute differences they have found from the given nums array are 0 and 1, and among them the maximum value is 1. And uh, you can also think that I'll just sort the array and I'll pick from the starting onwards. I'll pick the very two elements, and that will be the minimum. That then now I can achieve the difference. What I mean to say is, suppose if I have 1, 2, 2, 3, 3, 4, 4, and if I ask for p is equals to 2, you will say that I'll be picking the two. If you're thinking it in this way, this is wrong, because like you will be picking two values, that is 1 minus 2 minus 1, that is 1, and again here 3 minus 2, that is 1, and again here 4 minus 3, that is 1. It's not like I will sort the array and I'll pick the very two elements each and I'll give the first two values. That's not the correct way. That's because like we can achieve here 2 minus 2, which is 0, and 3 minus 3, which is 0. So maximum of 0, 0 is 0. So the answer will be 0 and not 1. This is the key point here. It's not a greedy algorithm. Now if I have now if I want to think it of using binary search, how can I do? I can clearly say that my value will be ranging from 0 till this last minus first value, 4 minus 1, right? Now post this. Now we have now I can clearly say that now I can clearly say that if I am able to so my values will be 0, 1, 2, 3. If I have a pairs, if I have a pairs which are which are having absolute suppose if I have k pairs, I am having a k pairs which are having absolute difference less than or equal to 0, then I will be having, and I have k dash pairs which are having absolute difference less than or equal to 1. I can always say that k dash will be k plus some delta. I mean k dash will be always greater than k, because I can say that those pairs which are having value less than or equal to k, less than or equal to 0, will be always those pairs I can include in the values pairs, the absolute difference of values which are less than or equal to 1 also. So the basic binary search will be if I achieve false on 0 and if I achieve false on 1, and as soon as I achieve true on 2, it will be true from then, while checking for that particular difference. We will go we'll code it up in the same way, step by step. So here given in that question that we define the maximum of an empty set to be 0, and here in the constraints they have given p can be 0. If p is 0, then they were saying that there is no the set will be empty, so I can return 0. Okay, now the basic thing is like I need to sort the elements, because I they are not considered of the order. The indices can be I comma j, any indices, 2 indices that need to be there. I sorted the elements. Now I'll capture my n value. Now I have two issues. I have my lowest index as 0 and highest index as I'll be creating my answer. I'll be initializing my answer to -1. Now I can clearly say that I'll be calculating the mid value. I'm assuming that everyone was aware of binary search. So I'll be calculating a function. I'll be having, suppose if I have a function is valid, think it of in this way. If I have a function is valid, and if I pass my nums and p and my value till which my threshold value, I mean till here, if it is okay, if this is true, then I can initialize my answer to that mid, and I can increase, no, I should decrease here, because you need to minimize the maximum difference. If I am able to achieve for 2, I need to check can I achieve for 1, else I need to increase it, and I need to return the answer. Now I'll be writing a boolean function. So this is basically the p is basically the requirement, and this will be my threshold value. So I'll be starting from nums of 1, and I'll be going till last size, and here I'll be checking if my nums of I minus nums of I minus 1, as it is already sorted, so this will always be greater than 0. It is less than equal to my threshold, then what should I do? I should decrement the requirement, and I also need to increment the I value, because I am using that index, ith index, so I should not use that again. Here this will ensure that I'll not use the I'll be skipping that to the next index also. And at any point of time, if my requirement is 0, then I have achieved the task which I was supposed to do, and return true. Else if I don't find any kind of thing, then return false in the end. Let us compile it and check it. Let us run this. Yeah, we are able to get the correct answers. Let's try submitting it. Okay. Yeah. What will be the time complexity? Time complexity will be order of time complexity will be order of n into, so uh, this binary search here includes order of log n. Why am I saying it is like the maximum high, suppose my highest number is n, and nums of 0 is 0, nums of n minus 1, suppose uh, n, and the highest difference, I mean low to high, it can be n, and I'll be doing the binary search on log of I mean nums of I, maximum value of nums of I is 10 to the power 9, 10 to the power 9, and minimum number of nums of I is 0. So the low and high can be low will be 0 and high can be values of 10 power 9. Okay, now I need to check from that point of view. I need to check that how much I can I'll be going through the mid index. So 10 to the power 9 divided by 2, so every time I'll be checking half of it, so it will be log n, log of 10 to the power 9, and for each of the step I am traversing the array entirely once. I can at max traverse the array entirely once, so it is order of n log n. Time complexity will be order of n log n, and the space complexity will be we are not utilizing any kind of space, we are not utilizing extra space anywhere, so it will be order of 1. And if you like my content, do follow my channel, and I am creating the DSA playlist where I'll be going through each daily problem, and I'll be solving it in the live, so that the viewer can easily experience. It will be easy experience for the user, and you can also easily code it up. And if you want me to solve any kind of other problem, do let me know in the comment section, and we can create this comment section as a forum. So if you have any doubts in that, you can comment it down. I'll reply on it. Thank you.